Alright, so I was in the last video talking about this. So when we look out into the night sky, and humans have done this for all of history, when we look out at the night sky, there are these certain patterns that I think is just part of the human nature to find patterns. Now they're all, different cultures have looked up at the night sky. It's always the same night sky, with the exception of where the planets are, which move around. But the stars are fixed with respect to human civilization. They do move around on their own, but they're so far away that their motion is not detectable to the human eye. You need a very powerful telescope to be able to see that, and it takes an enormous amount of time. In the order of hundreds of thousands of years. But like I said, you go back in history, different cultures saw different patterns in the night sky. This, of course, this picture right here is the famous Orion the Hunter. That's the constellation. So these patterns are different what are called constellations, and a lot of them come from history. Some of them come from mythology and so forth. Right now the entire night sky is covered with 88 recognized constellations, and they're just regions of the sky, right? Like if you look at for example, if you look at the states in the United States, there are some states where there's a physical reason to distinguish between one state and another. The Savannah River, for example. But if you look like, especially out west, some states are just artificially divided. When you look at the map, there's no physical reason why to distinguish between one state and another. And the night sky is very similar to that. There are these patterns that have agreed upon names, and these patterns have been divided up into 88 regions of the night sky. And when we talk about a particular, like this, of course, is Orion. There's the very bright star down here to the in the lower right hand side is Orion Alpha, the brightest star, and it actually has some of the stars just have proper names if they're particularly bright, like this one, which is called Rigel. It's not necessary to know that, but some of them are, they're not bright enough to have their own name, and so therefore they'll just have like a Greek letter associated with it, or even a number sometimes. But like all the stars in this particular region would be called Orion. Orion Alpha, Orion Beta. The Beta one is this star. This second brightest star. It also has a proper name because it's so bright. It's called Betelgeuse, or Betelgeuse, depending on how you want to pronounce it. Anyhow, this is the pattern that the ancient Greeks saw, and a lot of the patterns that we use are from what the Greeks saw. Because like I said, there were many cultures that looked up in the night sky. They had their own patterns. The stuff is the Greek patterns were written down, and we can still read that language, of course. All right, let me briefly talk about astrology, just very briefly, because this is of course not an astrology class. There are no college classes that are astrology classes, because astrology is a bunch of nonsense. I want you to understand that. I understand my position on that right away. But I can't ignore the fact that there was a mixture of astrology and astronomy, especially in the ancient world. you know, what we would consider astronomers were hired and paid to make astrological predictions. That is, you know, because of where the sun was on the day of your birth, you know, what constellation the sun was in, they made predictions about a human life, which, you know, really has nothing to do with anything. You know, where the sun was on the day of your birth, you know, will not predict what the future of a human being. Okay, it's complete nonsense, because, you know, every 365 people would have exactly the same future, which is complete nonsense. As the other thing about this is, and when we start talking about precession, the thing is, you know, when you talk about your astrological sign, these signs were, you know, where the sun was on the day of your birth. But the problem is, astrology goes back to where the sun was roughly 2,000 years ago on the day of your birth, and that's not necessarily the same as it is today. You know, and so you know, the modern astrologers don't even have the proper location of the sun on the day of your birth. So, you know, in other words, if you think you're, you know, a Sagittarius, you know, more than likely you're a Capricorn, because the motion of the Earth, or the wobble of the Earth, this thing called precession, has shifted the constellations of the zodiac constellations, and they're going to continue to shift as the Earth wobbles in its 26,000 year period of wobbling. All right. Anyhow, when we look at the night sky, the stars appear, you know, these patterns appear to be, you know, you know, two stars appear to be really close to each other. That's not necessarily the case. The stars can be very, very far apart. They just look the same in a two-dimensional sense, right? When we look out into the night sky, we get no sense of the three-dimensional nature of the stars, of how far away they are. It takes actual astronomical, you know, observations with a telescope, and the use of this for nearby stars, the use of this tool that we call parallax, which we'll talk about much more as the semester goes on. All right, so going to this two-dimensional space, you know, when we look out into the night sky, the ancient folks, mostly the Greeks, came up with this idea of what's called the celestial sphere. So this is just a simple, you know, a sphere that surrounds the Earth, and it's kind of like, just imagine like the different patterns, the different constellations painted onto this celestial sphere. The celestial sphere has a north celestial pole and a south celestial pole, and the north celestial pole is just the north pole of the Earth projected out into space, and the south celestial pole is just the Earth's south pole pointed out, you know, projected out into space. Now, for the north celestial pole, there happens to be a pretty bright star near there called Polaris. It's also called the North Star. Now, there isn't the same star in the southern hemisphere. There's not a particularly bright star that happens to be aligned with the southern pole. And now, I just mentioned this idea of precession, the fact that the Earth wobbles, and therefore this thing that right now in our current time, the North Pole happens to be, the North Celestial Pole happens to be pointed at a very bright star called Polaris, but that's not always going to be the case. So, you know, 14,000 years from now, there's some other star, I forget the name of it, but It's one of these northern stars, but I think it's called Thuban or something like that. Anyhow, 14,000 years ago from now, the North Celestial Pole will be pointed towards another bright star. All right. Let's see. So that's the just like the Earth has, of course, the equator. The Earth, if you project the equator of the Earth out into space, that's called the celestial equator. All right, and so and we divide. So just like the Earth has latitude and longitude, we have what's called right ascension and declination. The declination is the angle from the celestial sphere. Like 0 would be right along the celestial sphere, and if I can point at it, so this of course would be the celestial sphere. Points above the celestial sphere have positive numbers, so it goes from 0 all the way to 90 degrees, positive 90 degrees, and then if you're in the southern hemisphere, it goes, of course, starting at 0 to negative 90. Right? So anything that has a negative number for its declination, that means it's in the southern, it's in the southern hemisphere. All right, and then what about this thing called right ascension? So right ascension has to do with it's measured in hours, minutes, and seconds, and that of course can be converted into degrees as well. But that has to do with where it's actually Pisces. In the 2,000 years ago, the vernal equinox, the spring equinox, occurred in which was is March 21st, occurred in the constellation Pisces, I'm sorry, I got that wrong. Now, in modern times, the vernal equinox occurs in Pisces. 2,000 years ago, it occurred in the constellation that's right before this. Let me see if I can point. It's not on here, but right before it is, to the left of Pisces would be the constellation Aries. So 0, 0, right? 0 right ascension and 0 declination is actually it was defined a long time ago, 2,000 years ago, in the constellation Aries. Right, so in fact, it's still called the 0 point in Aries. So all measurements are with respect to Aries, as far as right ascension goes. All right, but like I said, nowadays in modern times, the spring equinox occurs in the constellation Pisces. In Pisces. It's 700 years from now, roughly 700 years from now, it'll occur in the next constellation to the right of Pisces, which is Aquarius. Because of this thing called precession, it'll go all the way around all 12 constellations of the zodiac. All right, let's see, how am I doing on time? All right, so there is this thing called the diurnal cycle. That this is just the motion of the motion of the sun, the daily motion that we see. Noon, of course, is defined as when the sun is the highest in the sky, your local noon. But the thing is, the Earth, of course, rotates on its axis once every 24 hours. It's not exactly 24 hours, by the way. It's almost 24 hours. But the thing is, because the Earth is going around the sun, where noon is, or if you look, noon, of course, you have the sun in the sky. But like if you look at where the Earth rotated with respect to the stars, like if you sit and you wait for a particular star to line up, like let's say you have a telescope in the backyard and you line up a particular star, you would think that 24 hours, you wait 24 hours and that would exactly line up, but it doesn't, right? It doesn't because, of course, the Earth has moved a little bit in its 365-day cycle. It's actually 365. Almost 365 in almost one quarter day, and so, that's the yearly cycle. So